record on this computer. And we're good to go. Welcome, everyone. This is another fun session of Deep Learning Adventures. Welcome new friends, welcome existing friends. Good to see everyone. If you're joining us from Meetup, you can find us under Deep Learning Adventures. If you're joining us on YouTube, we have several playlists. If you Google Deep Learning Adventures, you'll find us as well. And we have a few people joining us from Kaggle from time to time as well. And I want to make sure you feel welcomed. I'm George. I'm joined by my good friends and colleagues, Robert and David, as well as friends from all around the world and around the country. Today we'll be talking a little bit about a new, relatively new, about a month ago, summit that TensorFlow held called TensorFlow Everywhere. And it was a 2-day event. And really, we just want to share with you some of the key topics or key ideas that we find interesting and, just ignite some discussion among our community. So let me start sharing my screen. And share some housekeeping items with you. Again, this is the Meetup page. All our sessions are recorded. I'll post a link on our chat as well. As you've seen, we've wrapped up our Kaggle adventures. I think we have one more coming up, the very last one, on part 2 of reinforcement learning on 2 Kaggle competitions. We did one on a space simulation one. We're doing another one on Hungry Geese, which is similar to like a snake game, if you remember from the old days. We did a quick a geospatial bonus lesson on vaccine tracker. We saw some progress there across the world on how COVID-19 vaccines are being distributed, but really diverse topics, as you can see from our playlist. And next week will actually be our 1-year birthday or anniversary. If you remember, we started in April 2020 of last year. So maybe we should do something fun next week, in the beginning of the session. Maybe a little cupcake or something. Cool. This TensorFlow event, the link is on the Meetup page as well, was held on Feb 26, 27. A really well-organized event. They had great speakers. And I enjoyed not only the what is new with TensorFlow, but also what can you do with the TensorFlow ecosystem and how can you build cool applications. So I'll cover some topics that I enjoyed from day 1, and Robert's gonna cover some topics that he enjoyed on day 2. But really, if you want to take a deeper dive, we highly encourage you to check out the actual sessions. Let me post the TensorFlow Everywhere link in the chat so you can take a look. And if you want to look at our previous recordings, here you go. And usually people ask me about our Slack as well. We have a Slack channel. You can join us here. Cool. Awesome. So the way that we're going to do this is slides were a little bit tricky to get for this. They were not shared. So I took some notes on different sections. But really, if I found something interesting, I'm just going to forward the video on the corresponding topic. So the first one was by Lawrence, and he really gave an overview of, he was the keynote speaker for day 1. He gave an overview of the TensorFlow ecosystem and really how people have used tech to combat some of the challenges that humanity has faced in the recent past. So he started talking about a little bit of the ecosystem, how many people, how popular TensorFlow is, how many tutorials have been there, blog posts and books have been written, as well as how many people have subscribed on things like Coursera, like our community, or Udacity or Udemy, and so forth. Then covered a little bit about this ecosystem of TensorFlow products and how it is separated in training, the core concept of it, which is the save model, as well as deployment, and some new features that are coming up on each part. And he talked a little bit about the journey of TF, where 2.0, again, this is all news to us, but ego execution was by default. 2.1, TensorFlow, the TPU version support was there. 2.2, you had a major performance improvements on the TF function, as well as some new capabilities for profiling how your model performs on CPU, GPU, and TPU. 2.3, if you notice, a lot of data science work really focuses on data preprocessing. So the team there at TensorFlow, they spend a little bit of time in this experimental keras or preprocessing layers for keras. They also, in 2.4, they have some new features for distributed training. This is if you have multiple workstations. So if your model is complex and your data is spread out into multiple devices, you can do what is called distributed training. They also introduced this new cool feature of tf.experimental NumPy, where NumPy is basically the go-to library for doing any kind of low-level data manipulation. So this new library supports NumPy-like capabilities within TensorFlow ecosystem. A lot of performance improvements, as you can imagine, as well as some major refactoring on the Keras APIs and code for further reliability, stability, and performance. That was a good addition on 2.4. He then talked about a little bit. He broke it down into. Let me back it up a little bit. He gave some examples which I enjoyed on where is TensorFlow used in research, where is it used in production, where is it used in development, and as well as he talked a little bit about responsible AI, which I find really, really interesting. So he gave some examples in research for these papers or blog posts for detecting sign language from a webcam, or doing reinforcement learning at a massive scale, as well as this new feature, which I think TensorFlow introduced late last year, of quantum machine learning, and how that is used. To me, that's really advanced and really cutting edge. So that's on the research side. He also mentioned a little bit about this cool concept of 3D modeling and how you can actually use TF for 3D data, which I haven't personally seen yet. So that was something new to me. Yep, that was TF for 3D models. He mentioned this object detection API, which is new, I think, in 2.4, as well as a recommender system. So I'm hoping to check this out. I don't know if it's available yet. I think it is, but if it is, then maybe it's a layer, or there's a pre-trained model that performs object detection. That'd be cool to perform out of the box.
Yeah, one of the other speakers, one of the Google developer experts, used the object detection API in her talk for her project. So we'll see a little bit of that.
Awesome, awesome. Then, yeah, he mentioned TPUs as well. We've used TPUs in many of our Kaggle competitions, if you remember in the past. He also talked about now on the deployment side with TensorFlow.js, where you can actually do training and deployment on the browser. I haven't seen anybody do extensive training on the browser simply because it requires a lot of resources. Lawrence mentioned this cool demo. I haven't checked it out yet. There's this YouTube series called Made with TensorFlow.js. There's this Mona Lisa effect video where I think if you actually look at the Mona Lisa painting, you can, if you move around, you think that she's actually following you with her eyes. But this person made this video that her head also tilts where you are and tracks your position where you are in the frame. So she's moving her eyes as well as her face, and it's kind of spooky. He mentioned that was funny. There's some other ones that I would like to check out. Some funny, some serious, but something you can do on TensorFlow.js. I found that really interesting. Yeah, a lot of improvements on TF Lite, from performance to using recurrent neural networks, which are really resource heavy, memory optimizations, quantization, which saves a lot of space, and you just have a small trade-off in accuracy. Then he switched gears a little bit. He talked about responsible AI, and he talked about best practices, fairness, interpretability, privacy, and security. So he mentioned this interesting pipeline of when you when you embark on a new machine learning project, when you define the problem, when you construct and prepare data, when you build and train the model, when you deploy it, and when you iterate, what are some questions you can ask? So for example, who is my target audience? Who is my ML system for? Are there any privacy considerations? Do I need to that I need to be aware in the very beginning? And then when you prepare the data, where can I get relevant features in a privacy preserving way? Am I using representative data sets? We're going to see some demos where the TF ecosystem has some tools for us to look at balance or imbalanced data set. Or am I introducing any bias in my system? And bias could come, as you'll see, from multiple ways. One of them is through data. Another one is when you perform transfer learning, that model that was trained on a large corpus was probably introduced to some bias simply because the corpus itself had some bias. So you might think that just by using your data, but a model that you transfer and learn from another library might be fine, but actually there's a bit of inherited bias in that transfer learning process. Then, yeah, in terms of building and training a model, how does my data affect my model performance? There's another interesting concept that we'll see here with, I think it was federated learning, where if you have a query about a population, and if you remove a random person from that population, your query or your output of the model should more or less be the same by just removing one person or a very small percentage of the population. So basically, your model is not fine-tuned on specific topics of your larger population. Then deployment. Where and how should I deploy my model? How is the deployment performing? And then you iterate based on performance. You measure performance of your model, and then you iterate this whole circle. Maybe you need new data. Maybe you need a better model. Maybe you need a more narrow problem instead of solving a more general problem. So that was interesting. 5-step, 6-step process that he covered. Let's see. Before that, he mentioned this library, which we haven't used, that tf.privacy. This was new to me. I haven't checked it out yet, but I think this is a way to preserve privacy in your model. And I think this is from a paper where somebody was manipulating the data, and you can basically change the output of the model simply by introducing some very minute changes in your data. Another one, this really cool concept of something called model cart. This is regarding transparency reporting. It's almost like not like a summary overview of your data. So you can look at your training data here. It might be hard to see, but there are multiple categories, and you see that one of them is the majority one. So this gives you an overview of data balance or imbalance, and something to keep in mind. I found that very interesting. The other thing he mentioned was this tf tensorboard.dev. This is basically a place where people can share their models. They can share the performance of their models. They can share different metrics they're tracking, and it's almost like a public place where people can share their work. And that was interesting. He mentioned different user groups, started user groups all around the world that are doing cool things. That was interesting. Yep, supporting this Black AI community that he mentioned as well. Inclusiveness as well is very important for us as a tech community, but also for our day-to-day jobs. He mentioned this TensorFlow certificate that many of us have taken, and I remember when we took it last year, there were about I think 200 developers that have taken this certificate. Now it's I think 1K, and he mentioned it's coming close to 2K as of last month. Cool. There were some other cool features that he mentioned. Let me look at my notes here. So he mentioned this TF cloud, which was really interesting to me, where basically you can do your the machine learning building step as you've seen now, but in the end you can run it on the cloud. So that was just by one command, by this TFC or TF cloud command, something that we definitely need to check out. When he was talking about deployment, he was talking about some cool features on this phone. I have this Pixel 4a where let me see if I can find a video snapshot for it. But this was some cool features that you can have on your devices. For example, here, when somebody's calling you or when you're waiting on the line for a representative, you have this feature that you can tell the phone, "Wait for me," and the phone will basically detect if there's a human or an automated message. And then when there's a human on the call, it will prompt you to return back to your call. So that was a nice feature that's using TensorFlow Lite in the backend. The other one is using object character recognition and translating live from your camera. And the other one is using high definition, taking high definition pictures on the device as well. That was some cool applications. Yeah, so responsible AI, you mentioned best practices, bias. The bias can come from data or transfer learning, fairness, interpretability. TF federated, he mentioned an example of a Google keyboard where everybody types, or maybe types the same word, maybe in a different, not a different way, but with different speed, or maybe shortcuts a word different ways, or maybe you scribble it as people sometimes do instead of typing it. The other thing is that if you want to experiment with distributed training, you actually don't need multiple devices. You can just do it on Colab by renting a TPU, which underneath the hood has 8 cores. So you can basically do some of the basic distributed training examples by just using a TPU on Colab. That's the model card that we talked about. User groups. Yeah, that was Lawrence's talk. Very interesting. I like the examples he mentioned, as well as the responsible AI part. I think that was very interesting discussion. Cool. Any comments, questions, feedbacks? Now is a good time.
Can I ask a quick question, George?
Yeah.
I'm just curious about the algorithmic bias, or just the bias in general. Did they go into much detail about that? Was that something that, was it basically what you showed as far as the overview, or was there any discussion on, like, I don't know, maybe some detail on that?
Yeah, I think the next session talked a little bit about that. But I think they were mainly trying to give you the tools on how to discover bias. I don't think they went through an example end-to-end on their own. They showed some screenshots of projects they worked on and how they used this model card, for example, or TF validation to detect bias. But it's something that it's not fully solved yet. You have to be aware of it at every stage. From data collection, data preprocessing. When you do transfer learning, you need to make sure, at least need to be aware that this larger model was trained on large corpus that was probably inherited bias in it. So
I think some of what they mean when they say algorithmic is the actual architecture of the model can be biased if, when you did your hyper tuning of your model, like the parameters and weights and everything, you are basing that off the results coming from a biased data set. And now even if you try to unbias your data set later, but if you keep the same algorithm or model, I should say, with the same parameters, it'll still contain some of that bias. I haven't seen it proven, but that's I think there is a paper out on it.
I actually was reading a paper about it. It was just over my head, and I don't think I completely understood it. But it was related to this topic. It was IBM and Department of University of Michigan, and they were just talking about like putting constraints in and how there's a trade-off for the, I forget how they phrased it, but like the efficacy of the model as a trade-off for putting in constraints.
Mhm.
And those constraints were an attempt to control for what they perceived would be potential bias, but it maybe compromised the it was like a trade-off that they were talking about. And I recognize it's a pretty complicated problem, but I just was curious if that was maybe any new developments in that discussion in this talk in general.
Yeah, I think this next one might have something on it. Yeah, that's an interesting one. Cool.
Thank you.
So the second one was by Catherine Nelson. She talked a little bit more about responsible ML, which is really related to what you're asking, Daniel, and how TF extended, what tools the TensorFlow extended ecosystem has to help us in that journey. She mentioned this book that she wrote with Hans. Hans is also one of the speakers in day one on building machine learning pipelines. And the motivation for this was for this talk was about models being deployed in real products and maybe being biased. Maybe they were trained on a data set that contained probably representatives of one race, but then when they were evaluating on people from other races, they were not performing well. Or this project that Amazon had to get rid of because the training data was resumes, and most of the people applying there were one gender, so it was not being fair, or it was not recommending or candidates from the other gender, so they had to scrape that. So this is some of the things that she mentioned. This is on a typical journey of you have your input data, your data validation, make sure you do your EDA, and you see what is your data balance and things like that. Model training, model analysis, validation, and then deployment. But then what's new here is we have this metadata layer in TF extended, and this collection of tools that help you with bias, privacy preserving ML when you train, model fairness, explainability if your model allows that. And she also emphasized on human review and keeping a lot of trails and logs so that you can go back and see why or how a decision was made. So yeah, these are some of the components tools. We haven't covered them yet. I'm hoping our next specialization will cover some of them on data and deployment. And so she started talking about data bias, and you start with the data. Then she mentioned this data validation tools. Let me zoom in a little bit. But I think this is a nice feature. This is a nice feature that breaks it down a little bit into numeric features. It might be hard to see, but in categorical features. And it gives you some basic counts, like how many, this is zip code, for example, how many records you have of zip codes, about 27.9K. How many are missing? Less than 1%, mean, standard deviation, zeros, minimum, median, max, a histogram, and then similar metrics for like categorical features like count, missing, unique, top, frequency top, I guess, how many times that appears, average, string length, and so forth. That was an interesting, like, I would say data exploration tool. Another thing she mentioned is you can, by using this feature, you can see, for example, maybe you have way more data from one category than others. For example, for California, in this data set, you have way more data than other states. Something interesting that I liked is you can actually compare now. Let's see, you know that California is standing out. So maybe you can compare California with every other state. So you can see some metrics, for example, how many zeros are there for California, how many zeros are there for other examples. Or if you can see for maybe subproducts, how many subproducts are missing in California versus the entire other data set. The other thing that she mentioned is, let me see if it's here or later, that I think it was here. So for example, in California here, she mentioned something about, which I found really interesting, a data validation schema, where you can define basically what is allowed for your model to take as input. So I think you can do things like I will only allow features where the values are, I don't know, within 10 or 20% of the average value, something like that. So for example, if California had 10% missing values, but let's go the other extreme. Let's say California had 90% missing values for one field, and the rest of the states had, on average, I don't know, way less, like 10 or 20%. Then your entire pipeline, when it was processing data from California, would stop. Like basically, you can make rules that if you have a very imbalanced data set, or if you have a huge difference in one category versus the others, your training should stop and should give you a warning or a message that tells you that your data is either very imbalanced, or you need to manually validate and make sure that you're aware of this uneven distribution. So yes, you mentioned these parameters you can specify. I need to take a deeper look of how you define them, but basically you can stop the data and processing from training. So that was an interesting topic for me. Another thing she mentioned is this differential privacy that I briefly touched upon, but basically the idea is that the result of a query or of a model should more or less be the same if they run on one data set, and if you just remove a random person, more or less, it should be the same. Let's say you have thousands of people here and thousands of people here. The results with or without this random person should more or less be the same. So basically your model is not tuned to a very specific person, and this way you can, you're heading in the right direction of preserving privacy. She mentioned these tools that you can use in privacy. This was a little bit new to me, so I didn't spend much time in this. But basically you can define it as a new optimizer here with these new libraries. And then you do your regular compile fit journey as you do with Keras. Then she talked a little about fairness, demographic parity, accuracy, opportunity. She mentioned this new this website, gendershades.org, where I think this was like a comparison project for different classifiers, gender classifiers. So these are different models by different companies. I mean, this is not to point fingers, but just to give you an idea of how they perform on either different genders and colors, and what is the gap. So for example, you see here Microsoft model on a darker male is 94% accurate, on a darker female is 79% accurate, lighter male, lighter female, and what's the gap? So that's something that was an interesting analysis or project. I'm hoping the models now are more representative and the data they're trained on are more representative. This model analysis tool that she mentioned was really interesting. I think it gives you an idea of, I don't know if it does some kind of like elimination of, maybe it keeps only one feature at a time, or it removes only one feature at a time and keeps the rest. But I think it was trying to detect how does your accuracy changes if you remove different features, or if you experiment, or if you perturb a little bit these different features. So for example, you have like debt collection, consumer loan, credit card, product, and credit card reporting. And I think it was trying to figure out, based on this data set, if you remove maybe one feature, or if you perturb a feature a little bit, how does your classification output change? So I think here the goal was maybe accept or provide or deny a loan. So I think that's why you see this binary with the accuracy here. Again, they didn't go into this many details, so it was hard for me to to take a deeper look. Trust auditing. She mentioned that as well. She mentioned this cool tool, What If, and I think I've seen some YouTube videos about this, but I think you can change your inputs here, and I think you can see how does your model classify the outputs. Maybe it would be a nice feature to do that. So this was an interesting one. This counterfactuals where I think, let me remember, I don't know if this was for a loan or something else, but this is an example of for this person with these features on the left, the model gave one output, maybe loan was granted, but maybe for this person with this characteristics on the right, the model said given the opposite output of the loan should not be granted. And the only thing that changed was age went from 45 to 46. This, I know this is, it looks like a zip code, maybe, no. And also the occupation changed and hours per week. So by perturbing a little bit the data set, the model gave a completely different output. And we as developers, should be aware of that, these examples. She mentioned a little bit, yeah, this partial dependency plots that hours per week was influencing your model output a lot versus what education level. I think, yeah, what education level did not. So that was interesting. Then she also talked about human reviews and trails, human in the loop, where you can basically create your model and ask for your community to validate it. Maybe you have like a checklist of what are the things that you want to try and how can people give you feedback. Audit trails, that was interesting as well. This is basically housekeeping and making sure that whatever you train and whatever results you come up with, they're stored so that your team can look at them. She mentioned this Lineage Explorer, which was interesting. So you can have your data exploration or data transformation. You can have your training step and then your model. Then maybe you can see this model, how is it trained and what is the data pre-processing or the data access and data gathering part. That was interesting. Yeah, she mentions a lot of these tools, which, I mean, I've heard bits and parts of it, but it was nice to see that they could all fit in this TF extended ecosystem. Yeah, this what if analysis tool is interesting, and this model analysis as well. It's an interesting tool. I'm hoping we get to explore both of them soon. Cool. I'll quickly jump to the next one. The next one was not super technical. No, it was a little bit technical, but it was advanced for us. Josh is a great speaker. He gives amazing talks, and he talked a little bit about AI, machine learning, representation learning, and deep learning. And he gave a little bit of, I would say, a quick intro to deep learning. So he talked about the basics, the input layer, the hidden layers, and the outputs. I'll skip this, as we've seen multiple examples. So he mentioned some code examples. What is a neuron? What's an activation function? How do you go from one layer to multiple layers? And in the end, everything is just matrix and vector multiplication. So he just mentioned that, examples like that, which I like the way he explained it. It was very, very well presented. So if you're new to machine learning or deep learning, I think this was a very good talk. He also mentioned that you can use this for structured data. We've used deep learning for structured data. In this case, he talked about this miles per gallon data set. We're looking at different features like cylinders, horsepower, weight, acceleration. You need to predict this miles per gallon feature. And he said, make sure you use different models to validate, to get a benchmark. So you don't have to go with a state-of-the-art deep learning model. Use something, a machine learning based, like a tree-based model. Usually perform for structured data, as we've seen, they perform really well, sometimes even better than deep learning models, or many times for structured data. Then he talked a little bit about convolutional networks. He mentioned the tutorials in TensorFlow, fine-tuning when you do transfer learning, audio. This pick-to-pix was interesting. We haven't checked it out yet, but I think the idea is that you have a drawing, like a very high-level drawing, and the model is supposed to create a realistic representation of this drawing. So this is what the input was, this is the ground truth, and this is what the network came up with, which is very, very close. So this I think is, yeah, this is a GAN, yeah. So this is conditional generative adversarial networks. So we haven't come across them yet. Let's see, what else did he mention? Recurrent neural networks. He said you could do it something like sentiment analysis, which we've seen, or you can do text generation, which we've also done. Attention in machine learning translation as well. This encoder-decoder architecture we've seen in the past. Then he mentioned these books that he recommends, which we also recommend as well. The Keras one by Francois, the machine learning one by Leon, and the deep learning by Ian Goodfellow. So this was a good talk as well. So that was an interesting one. Cool. That was Josh. I don't know, questions, comments, feedbacks. The next speaker was, let me see. So Akaba here talked a little bit about recurrent neural networks, and he actually took a deeper dive into how recurrent neural networks work. And then in the end, he gave an example of using time series data. We worked with time series data in the past. And he mentioned a little bit, how can you maybe predict the S&P 500 using recurrent neural networks? Very controversial topic. So he talked a little bit about sequences, the recurrent neuron, the basic RNN, and how you unfold that, and what are the connections, from hidden layer to hidden layer. How do you do backpropagation through time? It's PPTT. He talked a little bit more advanced recurrent neural networks like LSTM and GRUs. We've seen both of them in our deep learning visualization. And then he talked about the data set itself, the S&P 500. Let me back it up a little bit. So this was, I think, 90 years of data of S&P 500 from Yahoo Finance, 1927 to 2021. And the libraries used, Pandas, NumPy, Plot, Keras, Keras backend, train test, and min-max scaler for normalization. And this is how the data looks like. We have a day, you have an open value, high value, low value, or price, a closed value, and volume. And what he did is so the goal was, given 5 days of prices. So for example, let's say that this is a sequence, a random sequence, 23, 65, 78, 06, 45. This is the input. So the goal was for the network to predict the next value, which is 08. So that would be our prediction. So basically, you're taking this batch of 5 inputs and you're shifting them by 1, and the goal is to predict the 6th one. So you're doing this. That's how you create the training data. Yeah, so basically his target, which is the next day close, was the date close, but shifted by 1. So if you see here, for example, for December 30th, the next day close is the previous or the next day close. For example, here, it was January 3rd. For January 3rd, the next day close would be January 4th close value. So basically he took the close date and he shifted by 1. This shift -1. So that's his target value. Some scaling, so the data is in the same 0 to 1 range. Neural networks perform much better when you scale them like that. Very important, when you do your train test splitting, you don't shuffle the data. Shuffle is false. Otherwise, you're not going to have any causal relationship in your data anymore. You should only look at the past and predict the future, and not mix past and future data sets. Some checkpoints. TensorBoard, use TensorBoard for tracking models. Early stopping for stopping the network from training if the loss does not change by 1,000th unit, as well as if it plateaus, you reduce the learning rate. Let's see the model that he built. A very simple one, sequential GRU, 128 units, the dense one in the end, mean squared error atom for optimizer, about 51,000 parameters. And then he looked at this time series. I don't think he plotted the MSE. He looked at the actual predicted closing, which is in red, and the actual one is in green, and the predicted one is in red. And as if you remember from our time series analysis, neural networks are not capable of extrapolating values. They're not good at predicting values they've never seen before. So if you see here, the trend is uptrending, but the neural network has only seen values within given range. This is normalized range. So it's basically having a hard time catching up with the high values. That was interesting to me. It reminded me of some of our adventures we did in time series analysis. And then he predicted what is the output on one day for S&P 500. He predicted 3,496. In reality, it was like 3,8 something. So it was like 400 units off. And then everybody in the chat started asking him questions. How is this compared to other more statistical based models? Sure. And his advice is like, don't do this for finance. He's like, make sure you take care of your finances in a logical way. This is just one tool that you can use, but please make sure you use other tools as well to do time series predictions. Yeah, that was cool. All right. Questions about this? Okay. And quickly, just for the sake of time, the next one by Tanmay was really interesting as well. He's a very gifted speaker. I wasn't aware of him. I learned of him through this talk, but he's a great speaker. He's written a few books on programming, I think. Yep. And he's given a few TED Talks as well. He has a very active YouTube channel, 300K subscribers. So very interesting. These are the books, some of the books he's written. Basically, I like his presentation. I like the layout of it. He talked a little bit about neural networks. He talked a little bit about reading and writing philosophy and language. He touched a little bit on LSTM RNNs. He talked a little bit about transformer models and GPT, and where does it see natural language generation? Where does it see it, moving forward?
One thing to point out, perhaps the most impressive thing, is that Tanmay is only 17 years old.
Oh, really? Yeah. Wow. Yeah. I didn't know that. Very impressive. Yeah. He talked about language and the classical approach to dealing with language and breaking it into parts of it. I'm trying to find a slide. And then he talked a little bit about deep learning, gave this analogy of, this is the iris data set, and he was basically trying to say that the whole point of the model was to convert your input data into representations such that they are linearly separable. So this is the iris data set in probably a scaled version of it. But the whole point of a model of it is to transform them into a representation such that you can easily or linearly separate one class from the other. The other approach is maybe when you train something, I think we've seen this, you can do this triplet loss approach where you have, this is where you're trying to train it to. This is a positive example of one class. This is, let's say you're building a CAD classifier. So you want to make sure that whatever weights and representations your model has for this input maximizes cosine similarity between these two inputs. They're cats, they're very different cats, but they're cats. At the same time, you should maximize, sorry, you should maximize similarity between them, and you should minimize the similarity between this input and this negative input, which is dog. It's not a cat. He talked, let me see, a little bit about language modeling as well. LSTM RNNs as well. He mentioned that what are some pros and cons of them, that they perform well, but they're not, they're very domain specific. If you train a recurrent neural network for I don't know, healthcare text, it will do very well for healthcare text. But if you give it as input, I don't know, art text, it will probably do very bad. And they can only see past or future at once, and they cannot see or past or future at once. They only look at one sequence at a time. They're very slow because they're recurrent by nature. They're hard to learn long sequences. That's why, you know, newer architectures like LSTM and GRUs were invented, but even they have a hard time learning long sequences, and they're very sensitive to hyperparameters. Nonetheless, they've been used in the past for, you know, different tasks like sentiment classification, recognition, emotion recognition, spam detection, and so forth. He gave a very simple example like Live and YouTube Live. If you use simple models like Word2Vec, they're exactly the same word, but the context is completely different. So that's one limitation of them. Then he talked a little bit about these transformal-based models where you can have a model that is almost deep pain independent. I don't know how true that is, but basically if you train it in one domain, you can maybe transform learn it in another domain and do some fine tuning. I haven't personally done that, so I'm not sure how true that is. Now you can see the past and the future at once. That is true, and they're parallel by nature, very fast. They can learn long sequences as well and perform really well. And the way they do that is by the way, or by an approach that we as humans learn as well, by masked words. So the input of them is this unsupervised approach where you have your input and you hide specific words, random words. And the whole point of the model is to try to predict those missing words. Word pre-synchronization. So in many cases, it might be a new word that a model hasn't seen. In this case, you can actually break it apart into something that you've seen and maybe something you've never seen before. Let me remember here. Then he talked a little bit about how we think as humans, or what does language and speed come into the picture. So you have your knowledge, you have your, you know, your sensory data, wherever you hear and see, your experiences, you form a thought in your mind, you convert that thought to language, and then you express that language through either text or speech. Most of the modeling, or the part where most of the research now is concentrated, is in this thought language part. But he said the way that we train our models is the reverse. We give them as input a language, we give them a large corpus, we're trying to make our model have some kind of representation of that language, basically think, which is the opposite way of how we do it as humans. And he said that's why we think that, he said, these models are good writers, but they're actually in reality good readers. He made that distinction. They can read a lot, and he mentioned some GPT-3 examples. So they seem really, you know, human written, or like, you know, syntactically they make sense, but conceptually there's like they contradict each other, or they're not bulletproof, basically. Then he said that that's not, I mean, people were saying in the beginning, you know, there's GPT-3 coming out, and people, you know, marketers, journalists, this and that, will be replaced, even developers. Like, no, not even true. He said that instead we should use generative models as an inspiration, basically to augment human creation. So he suggested this project, I think, that he worked on, where I think he was trying to combat this problem called writer's blocker, where you're trying to write lyrics or something, and you're just out of ideas. So he's working on this project, Auto Lyricist, and I think he partnered with these songwriters, and he didn't fully explain how was his product involved. But if I had to guess, was maybe these songwriters wrote part of the song, and then maybe they used his product to write the rest of the song. Then basically showed a demo of the lyrics, which I don't know who wrote, but the human or his model, and what does his model look like? But it gets a little bit repetitive, which, as you've seen from RNNs, that's usually the case. I can unmute here so you can hear it. Sorry, I have it on 1.5. Yeah, that was interesting. And then he had another performance play. Okay, that was interesting. But a little bit, it didn't fully explain to me how was the product used. That was done May. The last speaker was Hans for day one. So I'm trying to forward it to Hans here. There you go. He talked a little bit about, I had a hard time following his talk, maybe it was the last one, I don't know, but he talked a little bit about different approaches to having a successful machine learning pipeline in production. So he said this is like the typical setup, but this is not scalable or this is not reproducible, and not a lot of, it's not appropriate for a team to build on it. It's very static. And then he mentioned his approach at his company, and let me see if I can find his approach. Oh, he showed this interesting diagram of human needs and developer needs. So, physiological needs as humans, safety needs, belongingness, esteem, self-actualization. Then he mentioned it as data scientist, okay, comes with data. So let's log in sensors, external data, user-generated content, whatever it is, starts with that. Then moving storage, pipelines, data flow, where is it stored, and how, ETL, and so forth. Then some EDA, exploration, transformation. You clean the data. Maybe you have some outliers. You prepare it. Then you want to go from data now to information or insights, right? So you do some analytics. You figure out some features, some aggregates, some training data, and then you do some basic modeling. A/B testing, experimentation, simple ML algorithms. You could do some more advanced analytics like deep learning, for example. I found this interesting, this visualization that he shared. These are the blocks that he covered, and he for each block he covered what it is and some tool from TF extended that addresses this concept. So I could talk about data access, impact, experimentation, experiment tracking, data analysis, updates, testing, and so forth. I'm not gonna cover this. Check it out. This was a long and interesting talk. It had a lot of content to it. Yeah, that was very interesting. And he mentioned this TF extended libraries again that we haven't come across yet. So cool. I think that's it. I'm going to pause here. I'm going to stop sharing. So that was a lot of content. Check out the demos if you want on your own. I find interesting that they covered a lot of topics into this TF extended environment. To me, that was interesting, as well as this fairness bias conversation. I'll hand it over to Robert to share with us some of his ideas and notes and what he found interesting from some talks from day 2.
Can you see my screen?
Yes.
All right, cool. So day 2, we had a variety of use cases. I think day 1 was talking more about general issues. You know, you had Lawrence giving his talks on TensorFlow and recent developments in the TensorFlow ecosystem, new tools that are available. That was a really great talk for people, anybody who's in the TensorFlow ecosystem, just for situational awareness of what's out there and what's useful. The subsequent talks on responsible ML, privacy, and even the general talks on deep learning. But day 2 was definitely more on applications and things that people have done with the tools here at TensorFlow. And I mean, you definitely understand while taking in a conference of this sort that it's certainly a marketing tool for Google, but it's really very well presented. I would say that the vast majority of what I saw I was quite impressed by. So I just thought I'd share a few of the talks from day 2 anyway that I've had a chance to go through. So the first talk on day 2 was Be Bach on a Budget. This was Vikram Tiwari, who's a co-founder at Omni Labs. And he, let me see if I can step through this. Yes, he shared how his life goal when he was much younger was to become a rock star, and realized that it was actually a really easy process. There's only 3 things you have to do. First of all, you pick up a guitar. Second of all, you practice a little bit with a band, and then the third step is you play on a world stage.
All right.
It's pretty simple process apparently, but somehow he failed to make this track, and decided that he was going to come at this from a different approach. So yeah, rethink life choices there. He talks a little bit about sound programming to the rescue. I don't know if this page is active right now, rockstar.hisname.com. But he gave some demonstrations where he was just showing essentially what he did. I think when he was much younger and he was first trying to imagine what would it be like to write music from computer programs. So you get I guess I'll play a little bit of this here.
Then be in the background and just wave my hands over a guitar. Maybe that would work. Okay, let's try. Let's see if this machine actually works. So we talked about waves and oscillator waves and how those work. So
jump forward a little bit.
Similarly, sawtooth. Now you can mix and match around here and try to generate different types of waves.
So really just simple computer-generated sounds, and then he tries to mix and match and put them together, and you get to hear a little bit of what you might consider to be a composition. Now, of course, this is just a random collection of sounds and notes, and he says as much. And he says that it reminded him, the first thing he thought of when he heard this was, oh, it's Nintendo or something. I have to say that was not the first thing that came to my mind, but that's probably because I've spent more time in my life in university music courses and theory courses than I have total playing video games. Didn't have many electronics as a child, so. But I think, but he wanted to illustrate a variety of points and challenges regarding music generation. And he came back to, he talks about these three ideas during the talk. One, you can start with these sine wave generators, square wave, triangle wave, etc. But actual musical instruments create sounds that have much more complex spectra of frequencies, and they're a little bit more complicated to recreate. What the combination of timbres and the length, the duration of the sound when you strike an instrument. So that was one thing that he was saying you would have to write in some kind of, if you're using rule-based programming, you'd have to understand these kinds of things somehow. The other thing that you may have noticed, or the last two things here you may have noticed from the example that we just heard, is that the order of placement of tones matters a lot, and that pure randomness is bad. Neither of if you have tones that are in random orders and just random tones all over the place, it doesn't really sound like music. So he goes in and he says, and then he starts back on a bit of an educational journey. This is his motivation for his talk, but he doesn't really get back to the music generation for quite some time. Goes into a lot of theory, describing neural networks, shows you this pretty cool tool that we played with last year at playground.tensorflow.org.
Mm-hmm.
If you are new to neural networks, this is a great way to get a handle for a lot of the design choices and tuning mechanisms that affect the nature of these things before you have to actually do any programming. So it's a very, very cool little hands-on tool. What else do we have here? He actually spent quite a bit of time on TensorFlow Playgrounds. Talks about a few other applications before coming back to TensorFlow.js, and motivates the TensorFlow.js, saying that there's 3 different kinds of things that you can do with it. You can run existing models. You can, so that this might be just straight out of the box inference. You can retrain existing models, take a MobileNet or YOLO or any other existing model, throw a different head on it, transfer learning. Or you can eventually learn how to write your own models and train from scratch. And you can do all of this in TensorFlow.js. So he goes on a little bit, does a interesting demonstration of a toxicity classifier. Again, not really the overall topic of his talk, but just demonstrating some of what you can do with TensorFlow.js. Let's see, eventually shows a little bit of the inner workings, platforms. Let's see, and then he finally gets back to the original topic, which is how might one do music generation. And I think he's trying to solve, remember those 3 challenges that we saw earlier, where one of them was the inability to replicate sounds and different frequency patterns that you might have heard earlier. Another one is the fact that it very much matters what order you put the tones in. You can have an ascending scale, a descending scale, and humans hear these things in very meaningful ways. And the third challenge that he talked about was the fact that you need to have some overall structure that can tie your composition together, even if you have scales and arpeggios and other types of musical devices, if they're randomly oriented one kind of after the other and they don't bear an overall meaning to each other, we don't generally appreciate that as a musical piece. So he describes a few approaches for solving each of these three challenges respectively. So for the first one, the sounds, replicating the sounds of instruments, he talks about style transfer, which is something that you can see in some of the courses that we've done as a group. I know the Andrew Ng machine or deep learning, I think the sequence models course that he does has a whole unit on style transfer. I don't remember if we did any of that in Lawrence's TensorFlow in practice. There's a pretty cool video here that he shows where he's taken a camera image of a dog and has basically got the...
Well, this is like very early in the days of TensorFlow, where it started with taking the artworks of historical significance.
Taking the camera image of the dog, and you can see the dog moving just as it is on video, but you've stylized the dog in a way that resembles certain historical works of art, for instance. So then the recurrent net is his approach to dealing with the ordering. The idea here being that recurrent nets are pretty good at dealing with sequences, so he shows a couple of examples of how RNNs have solved that problem. And then the third problem that he talked about earlier, the need for an overall structure to tie the piece together, is where he introduces the concept of autoencoders, and in particular variational autoencoders, which are a type of neural network that are U-shaped in the sense that the encoder typically starts with a lot of features, a high dimensional space, and somewhere in the middle you have a very sparse representation, a low number of features, where you've really compressed your original input down into something that can be represented with a small number of coordinates or small number of features. And then you have a decoder on the other end. And when you train these things, you can actually train them in an unsupervised way. You can, say, give it an input of a face or an image or it doesn't have to be image or video. It could be audio. It could be any highly dimensional data sample, and you want to essentially have it learn to predict itself. And the idea here being that, well, that should be a really easy task for a neural network to do if you've designed a big net, but if you've constrained it in this way by putting this bottleneck in the middle, then what you do is you force the network to learn as small a representation of the object as it can. So it's sort of like the neural network's equivalent of a principal components type of breakdown, where you're really just trying to develop a very small representation using a small number of features, so that this Z here might not have the shape of each of these cats. It might just say, does the cat have whiskers? How many? Is the cat's face round or oblong? And then at some point it can reconstruct from this very sparse idea. So the idea here being that you could do this with music as well. What if you start with a fairly, let's see, let's jump ahead to the, I think we have a pretty cool audio here where he has a music VAE. This is through the Magenta software through TensorFlow as well. This is a pretty cool tool, but you can hear a little bit of this.
And based upon this input data, it is trying to generate a sound. Let's try to play it around. Now, I don't know about you, but that is fairly good sound to me.
That's a
And
simple.
to train this model, you didn't have to really write.
That's a simple start, and he does go on a little bit further and shows how he can take building blocks like that, and the model can learn through using these variational autoencoders how to use that same building block throughout the construction of an entire song. So that was a pretty cool example. We get a little bit, let's see. Then he, of course, wants to get back to Bach and shows a few examples of attempting to emulate the style of Bach. And I think at some point there's an audio sample of that, maybe.
And as I promised, you can be back on a budget. You don't really have to do anything. You just use the existing model.
It's been here. So, anyone, if one is familiar with Bach's music, it does contain some of the harmonic stylization, and reasonably impressive place for a non-human model to have gotten to. The other point that he wanted to make was that one reason that developers in this space have focused on classical music in large part is that that has more public domain music available, and he's hoping to augment the training corpus and is suggesting that people publish lots of music in the public domain. So we'll see what happens with that.
So was this his project, or is that what he came up with? This generation of Bach?
I think that may have been a Google snippet when they were honoring Bach's birthday.
I remember that actually. That was like over a year ago, and it came up in, like you were saying, I don't know if it was Bach's birthday or not, but you could put in a couple notes and then it would create a 4-part piece around that. I thought you were saying this is the guy who created that, but I definitely have seen this like over a year
ago. If I recall correctly, Bach's birthday is actually in late March, so we should have just passed it again, I think. But I think, yeah, it would have been some anniversary in a recent year, yeah.
But it was a generative model, right? You just gave it a simple input and it tries to generate something like Bach because it was trained on Bach notes and music.
I don't know if you give it an input or if you're just taking random draws to generate the motives as well.
Okay. I want to see if he becomes a rock star or not.
So the challenge, he was trying to solve he's tackling 3 different challenges in order to do this, right? So he had to tie all 3 in for the. I'm sorry, I just went mute. He was trying to tackle 3 different challenges in order to generate the music, correct?
Yes.
So in the end, he needed to tie them all in order to get the final product, right? And so he had to solve 3 problems, and the variational autoencoder was only one part of it.
Correct. Yeah, that's how he presented it. He had the style transfer, the RNNs, and the variational autoencoders. And there was some point I skipped through it pretty fast, but I believe some of this stuff here may have been, I'm not sure exactly what part of this is his contribution. I got the impression that he spent much of his talk really focused on TensorFlow tools and how you can use them in your own work, and relatively small portion of the talk focused on the nominal topic. Okay, let's move along to the Jason Mays talk.
Robert, can I ask you a favor? Next to the full screen to the left, there's a theater button mode to the left of full screen.
This one.
The one to the right? There one. There you go. Click that. Perfect.
Okay.
It just puts the chat underneath it.
Oh, I got it. Yeah. So let's see. We'll move on to Jason Mays' talk.
So I guess he became a rock star, right, Vikram?
Perhaps.
He made it to TF everywhere, so let's say yes.
But he did make some comment about how he's pretty sure that more people have seen this talk than would ever have watched his concerts had he pursued those paths.
Cool.
All right, so Jason Mays gave a talk next here. See if I can get the title up on the screen. Because it's earlier on. Well, in any case, the title is, his title is he's a senior developer relations engineer at Google and developer advocate for TensorFlow.js. And he gave a talk essentially with a superpower theme, next generation web apps that one can develop with TensorFlow. So this was kind of a fun one. I wanted to... there's a lot of background here. Oh, that's why I didn't take notes here at the beginning through the background. A lot of the same stuff that we've covered in earlier talks.
Mm-hmm.
But then he starts to talk about all the different types of places that you might want to use models, and the argument for a JavaScript version is that JavaScript is so ubiquitous across all of these different domains. It's used in browsers, servers, mobile, desktop, Internet of Things. You'll see Node.js, React, Raspberry Pi, and he'll show examples using a variety of these things. Then he gets into he really jumps into the examples. There's talks about object recognition with Coco SSD and how you can run these things in TensorFlow.js. He makes a little bit of a distinction between object recognition and image classification. Object recognition, of course, you get bounding boxes along with the identification. He makes another argument for running at the edge, talks about privacy concerns and about how many people would like to keep as much of their data to themselves as they can, and about how TensorFlow.js enables that to happen on devices that may have easier access to JavaScript than any other. Let's see, we have goes into another example here with face mesh, where they've actually mapped out a variety of landmarks on the human face and used this to market makeup and lipstick virtually, I guess, by just putting it on the model's face virtually. So
Cool.
Talked a bit about that. Then we have an example here on body segmentation, a little video where you see we're able to segment out and follow all the people, and we see that we're not only detecting the people, but we also have waypoints at various important joints in their bodies, so we can detect when arms are up.
Cool.
And he talked about a number of applications for this, many of them in the fitness realm, something to do with yoga, counting reps for a variety of exercises. And then he had his own example, which was his first superpower of the day, I think. He built himself an invisibility cloak, and apparently did it in just 1 day of coding, which I thought was pretty impressive. But you can see the original video on the left and the invisibility cloak on the right. With that segmentation, he's able to only update pixels that don't have his own body in them. So you see the bed kind of reacting to him. You see that he's taking the step on it. It's not perfect. You see a variety of pixels that don't update immediately, but not bad for something that you're almost doing out of the box, apparently.
Nice.
I believe somewhere in the talk, I'm not going to share it here, but somewhere there was a GitHub link to the code that he wrote for that, so you're welcome to play with it yourself, the invisibility cloak. Here's another example with somebody projecting lasers out of his eyes.
What is going on?
Just another superpower.
All right. Is flying there?
No, I don't think we got that one.
Only
There's
super.
another one. There's another one here with teleportation,
Okay.
where he, essentially takes video of himself in his bedroom and then moves it as if he's in the hallway instead. You can kind of see some of the effects. It looks like the raw video is very backlit. And you can see that there's a lot of lighter pixels right around him.
Yeah.
You also, if you look at that a little bit more closely, you'll see that the shadows don't really track because the segmentation is ignoring those. Then at a little bit further here, oh yes, clothing size estimation. This was a pretty cool example too. I can definitely empathize with his motivation for sharing this one. I'm not a huge fan of spending my time trying on different sizes of clothing, yet at the same time, it's difficult to find something that really fits right. So the idea here was if you just feed in your height to the model, and then you take a number of images so it kind of gets your full shape, that can then recommend for a given brand and a given design of clothing, what size should you get. I've definitely seen, it's been a while since I read about it, but I've seen some ML models and some companies working in this space as well to not only recommend sizes, but also recommend styles and everything for people based on their body shapes and based on other people's choices.
You got M. Taylor. M. Taylor, they tailor your clothes based on, you take your cell phone, put it at a certain distance from you, and it'll measure you with your cell phone. And that'll tailor the clothes for you.
Yeah. Another company I've heard of in this space is Stitch Fix out of San Francisco.
Mm-hmm.
So then we got to see a couple of examples with Teachable Machine. So if you recall, we did an event on our meetup back probably 5 months ago or so, where you looked at this Teachable Machine with Google. And we spent the evening playing with 3 different models here. I think there's images, there's an image classifier, there's an audio classifier, and there's a pose. I guess they're all classifiers. Pose classifier as well. So we have the video up on the Deep Learning Adventures YouTube channel. You can see that one.
That was a cool one.
He talked about some examples where people are actually using these really simple models with simple sensors to detect things like daylight versus darkness and automatically closing their garage doors when it gets to be dusk. Then he goes a little bit more into how do you use these things away from the applications themselves. At some point in here, he starts to talk about production ML, cloud, auto ML, and then after auto ML, then he gets into this part about writing your own code in TensorFlow. Spends a good amount of time on that. Shows performance to be pretty reasonable in Node. I think the first bullet there is Python. In Node, apparently you can deploy in Node.js. You can deploy a server-based model without having to convert it to JS at all. You can run a native Python model in Node. But typically on the client side, you will need to convert a model using TF.lite if you want to deploy it. A little bit of profiling here. I think the motivation that he wanted to share on this example was the fact that a lot of times a significant part of your pipeline is the processing, pre-processing, post-processing. And if you want to use a model that's built in Python or some other tool, but you want to actually interact with your users and get your data and give your output in a browser, which may be running more natively in JavaScript, sometimes that difference in not having to port in a model from some other language can actually save you quite a bit of time, and you earn back this performance difference that you saw here, which was really only 10% or so between the JavaScript Node version and the Python. Then he goes on and talks about advantages and disadvantages of server-side and client-side deployment. Pretty interesting, pretty useful analysis of it. I'm going to skip all that just to not spend too long on this talk. There's one more that I really want to cover, and we'll jump ahead to that one. Are there any other questions on Jason's talk before we go ahead?
So just to clarify, was the goal to compare Python versus Node.js? Is that why he was showing those graphs and those metrics?
Yeah, just to show how Node.js, or to show how JavaScript deployment can be comparable in inference time.
Inference time, okay, got it. Cool, thanks, Robert.
So then we'll skip the Zero to Hero talk here by Lawrence Moroney. I think that's another talk that's aimed more at the beginner and interested learner, if I recall correctly. Did anyone watch that one?
I skimmed through it like really quickly, like you're doing now.
I've seen a previous Zero to Hero by him a year or two ago, and a year and a half ago or so. I wonder if it's similar. It's like a very basic introductory for beginners, and really great, but short.
So the one I really wanted to go into was this one by Lee Johnson, which was a pretty awesome and very comprehensive talk on the variety of challenges and tactics that one might take when involved in ML ops at the edge. And her problem that she was attempting to solve, well, I guess her initial motivation was to figure out how to take her Raspberry Pi, which she was enjoying playing with, and make it so that it could be used in conjunction with imagery and start to do something useful. And the problem that she got into was 3D print defect detection with computer vision algorithms. So let's see.
I thought she was going to detect if my frame is positioned right or not.
What was that?
I thought she could tell me if my frame was positioned right or not.
Frame.
Like if it was 0 degrees or it was tilted.
So this is very much a deep dive, and I think that it's a very dense talk, and there are a lot of places where she just kind of flew through it and just mentioned a handful of points on each slide. She seemed very enthusiastic about anyone reaching out to her with questions about this, about the material in this talk. She seemed very passionate about everything that she had put together here, and it was a very impressive project. So she did begin by saying a little bit about motivation and some of the challenges involved with companies and their adoption of machine learning in 2020, 2021. And she mentioned that applying to embedded systems and predictive maintenance are two of the major uses that are happening currently. She mentioned this after indicating that over half of potential consumers in the AI ML market are, and by consumers I mean businesses, companies, over half of possible users are still in the what can this do for me phase. We haven't really even begun to think about how we would actually use it, but just in the interested, but hasn't really done anything with it yet. So a lot of opportunity, but she wanted to look at things that have been done currently, or that are being done right now, and embedded systems and predictive maintenance are two big tasks. Machining, industrial uses, and 3D printing is a great use case for that, which is not only highly used in industry, but also has a lot of hobbyists and would be useful for a number of very small businesses as well. So she talked about that problem a bit. She goes into a little bit of detail about 3D printer types, comparing and contrasting the ones on the left, which are low cost, used by hobbyists and the small time players, and the stereolithographic methods that are used in higher end operations. And her market segment here, she's definitely aiming at this end, trying to improve the fused filament fabrication, which is essentially molten plastic at a very high temperature, 200 and some 220 degrees Celsius, over 400 Fahrenheit, and you basically try to paint it on layer by layer and just build up whatever it is that you're 3D printing. And so it requires a lot of precision, and it also is very useful to have an automated monitoring system that can tell, is something about to go wrong? Because if it does go wrong, there are a number of hazards that could happen since you're working at such high temperatures. She goes into some detail here of the problems. And then there's two choices, really. Do you use a binary classifier on this and say, take a whole bunch of data, fail, not fail, fail, not fail? Or do you build this much more complex model, but that at each step of the model, it's a little bit easier to explain what's actually going on? And because she wants to do monitoring and be able to warn in advance of failure, not just warn, but actually there's a control mechanism for automated shutdown as well, with the customer's permission. So here she's basically taking an image, doing feature extraction on this. There's a pretty cool video that starts at, I'll put it back to 232.10. You can see how there are basically 6 classes of objects that are being looked for here. There are, I think it plays a couple of times, but there's a background, that's one class. There's the actual print object is the second class. The raft is some kind of waste material here on the bottom. The nozzle itself is just this this piece right here. And there's also there's adhesion material and spaghetti, and these typically occur after minor failures, and they can be waste products as well. So the idea was to be able to detect and classify each of these things and draw bounding boxes around them, just to make sure that you're still in accordance with whatever the original planned object was. She determines that this method here with all of these different steps was the better way to go for a variety of reasons. But the main reason being that if you have this binary classifier, you're going to have a very difficult time assembling a training set. Let's see. She goes on to product maturation. There's a couple of steps here. So the rest of her talk, she talks about basically the 3 steps to bringing this thing to market. She ran prototyping on prototyping the path. She basically built a pretty simple prototype, tried it out, was able to train it used AutoML actually at Google, spent about, I think she said $120 in credits to train this thing, and saved her many hours of having to run those models herself. So in that case, at least she was appreciative of that.
This for the computer vision models?
This is for the computer vision models.
Oh, nice.
Yeah. And then after she's done with that, there's a refining step, and during the refining step, I think she talks about the prototyping for the next 10 minutes, I guess. Then you get into the refining part here. She's finished with the prototype now here at 250. You get into the, at some point back in here, she's done with the prototype. Now she's moving on to the refining. And the refining is largely, she describes a number of improvements to the outputs of the model, and in particular to the continuous learning, like how do we want to monitor, what kinds of things should we be looking for, and how do we quantify the health of the printing process, because what we end up with is really just a big time series of data. So to determine whether something has crossed the boundary from a okay to a failed state, and to make the right decision on that is a process that required a fair amount of back and forth with the initial beta users.
Just from my understanding, was her approach that if the model detects spaghetti, then shut down the machine? Is that the major role of this computer vision model?
If that's what happens, it's not encoded explicitly.
Mm-hmm.
But the idea is to have an automated control mechanism. She does talk a little bit, I completely skipped past, where she had certain design requirements. The one single most important design requirement was that the actual model running on the edge at the 3D printer had to be capable of functioning without internet access, because internet could be unreliable. You want it to be able to make the right decision to stop an unsafe process without relying on whether Verizon or Comcast signals are coming in, or whatever your provider is.
Got it.
And there were a couple of other design considerations as well. She goes through the refinement process, and then at the end she talks about scaling up. Right now, there's demand is 1,800 requests to join the beta, only 200 invites so far. So she's definitely trying to explore ways to scale up. And I think there's only a couple minutes here before the talk ended. Just working on ways for distributing training, and then some improvements. She says she's looking forward to also implementing some of these new tools through TensorFlow Extended to improve the data validation and some of the visualization as well. So a lot of really interesting stuff here. I mean, I think I couldn't possibly do this talk justice. There were so many. Every slide had. It's amazing how many different technologies were combined to produce this pretty simple sounding product. But there's a lot of different things that had to go into it, both software and hardware. So I think there was a lot of expertise that she had to very quickly gloss over while describing this project.
Is it true in the beginning of her talk she mentioned she was not familiar with computer vision at all, or was she?
At the beginning of her talk, she did mention that that it was very new to her, and she wanted to offer herself as an example of someone who really embodies the you don't need an advanced degree to do this stuff. Right. I think she said her most advanced math was algebra or linear algebra or something. But she's a programmer and a hobbyist developer, and she's a engineer or a developer at Slack, I believe.
And her beta program, is that a combination of hardware and software, or just software that she offers?
So she's using this, where is it? 240.
Is it like a camera or Raspberry Pi and a trained model?
So yeah, it's a trained model. I mean, and the Raspberry Pi is the deployment device and the sensor, but the actual model is being hosted through this service, OctoNanny or OctoPrint, and Nanny is essentially the nanny watching your 3D printer, and I think this is the interface that she's using and has been building monitoring tools out of.
Cool.
So there were a couple more talks at the end of the day as well. There was, I guess, the one on the magic and science of AI by Gant Laborde, and there was also a very short but pretty good talk by Pooja Rajan on how to get started as an MLE and how to break into MLE as a career. So those were, if those are topics of interest to you, that's a good place to start.
Yeah. Thank you, Robert. That was super useful. I can quickly touch the AI science one if anybody's interested. It'll only take me 1 or 2 minutes if you stop sharing.
I can do that.
Thank you. Thank you, Robert. That was super useful. I'm glad that the second day was more on application side than compared to the day one. this AI science by Gant was an interesting one. So he's I think a web developer, and he was saying, okay, we've seen cool applications using the MNIST data set, but we can build something cooler. And basically he goes on to say a little bit more about TensorFlow.js and what cool things you can do with it. Then he wanted to make this classification model of, could you distinguish something from like a Harry Potter environment? So a lot of people are aware of the books. They know the different schools. Can you build maybe some kind of a model that you start drawing a picture, like hand drawing a picture of something, and then you can classify it, you know, by different schools. So like a lion, like a badger, a serpent, or a raven, and they have these different names for houses, I should say. So this is interesting. So this is checklist. Should be an interesting and relatable problem or theme. And a lot of data needs to be out there, or somehow need to generate a lot of data about it. Simple TensorFlow.js model, and possibly host it somewhere, as well as a ability to expand this. So where do you find data? He mentioned this Quick Draw website where you can make human doodles. There's 345 categories that are readily available. And I think he searched for hand-drawn pictures of tigers. Is there any tiger here? Maybe here. Snails, parrots, squirrels. I think he was able to extract about 10,000 images of each category, which is a pretty good data set. He looked at it, I think, using some Disney representation. Talk a little bit about cleaning the data. He mentioned this other data set. I haven't used it before. 10 possible classes, small memory friendly. Not sure how he used this. So basically through that quick draw, he was able to get the data. Next, he wanted to build a model that, based on a quick draw, like a doodle, would classify the input in one of those 4 houses that we saw from the Harry Potter theme. And a very simple CNN model here, followed by a DNN in the end. Talk a little about convolutions. He talked a little bit about max pooling as well. He showed a really cool video of max pooling, which I feel obligated to share with our community here.
So if you'll indulge me for a moment, I will play this video.
This is in 5x, so it's going to play fast. So this is a picture of a dog.
Now, if you take a look here, it's been cut into slices, and then he breaks this into 2 different images of a dog. Does that look like 2 images of a dog? Yes, it does, but it's already been cut. Now he's cutting it along the up axis, just for a moment here. And he's breaking that into 2 different sections. And lo and behold, 4 images of dogs, a quarter of their original size. Would you say that each of those are a dog? Yes, you would. Amazing. So max pooling is effectively doing that. Luke?
That was interesting to me. So you slice the picture of a dog vertically and horizontally, and you're still able to recover it by subsampling it. So that was like one example of, I don't know if it was max pooling or subsampling, but it was interesting to me.
Seems like that would be more just subsampling.
Yeah. But the information is still preserved, right? Because, I mean, our brain can reconstruct it. Yeah. Some of them don't have eyes, probably, yeah. Part of the eye, but the major features are there.
That's pretty cool way to visualize it, to think about it, though.
Yep. Then he talked a little about his CNN architecture, 128.10. And then he started playing a little bit with it. So he showed this demo. So he trained it on his doodles. So you see you have a lion, the badger. You start with a circle, and the model thinks it's a snake. Then he keeps adding to it. And then the model thinks now it's a raven because of the beak and the eyes. So that was interesting. That's a snake. And he's trying between a badger and a lion. Now it becomes a lion. So that was an interesting one. Then he talked a little about, okay, this is on the Harry Potter dataset. Can I expand this on other datasets? And he talked a little bit about, I can take my trained neural network and maybe, I don't know, retrain it or continue to train it on a completely different environment, on Star Trek. So you can recognize the badges of Starfleet Command, the Klingon Empire, or the Ferengi Alliance. And he started, again, creating 50 new images of each category. So he got his previous model, and then he got rid of the last layer, which only had 4 outputs. Now he needs 3 outputs. And then I don't see a CNN here. Maybe the CNN is in his previous model. Then he was able to draw some pictures of a different, there you go, of different categories. This was Starfleet one. He's a good drawer as well. Hang on. It's the Ferengi one. All right. So that was most of it. Interesting applications, I would say. Yeah. He also mentioned this book. You can tell he's a cool web developer. Yep. Cool. That's most of the talks, friends. I'm glad you got to see it. Again, if you found something interesting, feel free to check out the actual event themselves. So this TensorFlow Everywhere actually is still happening, I think, but it's happening in different languages and different locations. I think there's 9 locations around the world that it's happening. I know there's one in India that happened, or it's already happening. But I think it's like a global event. Cool. All right, with that said, thanks for joining us. We have a couple more sessions before we wrap up our journey here. The next session is an overview of some notebooks with highlight and Kaggle competitions and Hungry Geese and other reinforcement learning competition. Dimitri and Alexander are going to cover that for us. And Robert and Kathleen, if I'm not mistaken, are going to talk a little bit about a revisit of this Pedals to the Metal project that Robert had built in the recent past. So looking forward to that. After that, we'll switch gears to the data and deployment specialization. So if you want to check it out now, do so. Check it out on Coursera. We're moving, I think, pretty fast on it, unless it's super complicated. But I'm hoping we can do maybe a couple of weeks in one session of content. We'll see based on how complicated the topics are. So this recording will be posted maybe tonight or tomorrow here, and yeah, that's this TensorFlow Everywhere. Check it out if you found it interesting. Let me stop sharing.
Thanks, guys. You guys kept us interested for 2 hours.
You can watch the 2 recordings for 8 hours, or you can watch us for 2 hours, and you're good. We did a autoencoder for you. Right, Robert, we kept the features that were important, hopefully. Yeah, some of them were very interesting. Some of them were like, okay, new feature, but some of the applications are like motivate you, okay. Like that invisibility cloak. What in the world? How did that guy do that? Cool, friends. I'll stop the recording here for YouTube. Thanks everyone for joining us on YouTube.